Attritable systems has been one of the most popular phrases in the defense space in the last decade. In the last couple years, I feel like you hear it every other day out of some pundit or military commander's mouth. But what is attritable? Attritable refers to unmanned systems built to be expendable, designed to complete missions with the expectation that they might be lost in combat. The United States has been addicted for a very long time to big, expensive systems that we use multiple times, or if they are going to be used one time, they're very precise. Unfortunately, in the last couple of years, we've lost the monopoly on precision that we've enjoyed for decades. Now, small, lower cost systems can also be precise and can also hit targets based on GPS or even based on someone navigating it directly into that target. The next frontier of attritable systems, though, is like onboard image recognition and terminal guidance, meaning a drone will get in the air, it'll find a target, and then it will run into that target all without you having a human intervene in that process. So today what we're going to cover is where and when the attritable shift started to happen, why stockpiles alone don't solve the attrition problem, how attritable systems win contested environments, where distributed manufacturing fits into the story, why centralized manufacturing still matters, and finally, what it takes to make attritable mass real. Let's get into it. When did we start seeing the shift to attritable systems? The first time I personally saw it was in the days of the first defense company I started, Citadel. ISIS bought a very large number of DJI drones and started using them and modifying them in an attritable manner so that they could either call out artillery coordinates, coordinate vehicle-based explosive devices, the VBIDs, if you remember those up-armored trucks, they drive into stuff, and also kamikazing and dropping bombs on soldiers. But they bought something that was a couple $1,000s and started using it en masse. The next place we saw this in a big way was in the Armenian-Azerbaijanian War, where attritable systems really made their debut and allowed for one of the forces to overwhelm the other. Now, I would say those are kind of like the early kind of, innings of the ball game when it comes to attritable systems. But the war in Ukraine obviously has really put this on the map. You've seen the Ukrainians basically start to take away the monopoly of precision that the United States and Russia, with their very big, exquisite systems, had when it comes to using precision to make attacks. Now, you have small, low-cost, mass-produced systems that are attritable that basically blow the monopoly on precision wide open because they can find coordinates and targets on their own, or they can be used kind of like bullets by pilots as they go look to strike vehicles. So, what has changed in the last couple years? Well, we think that if we've learned anything from the war in Iran, one is that centralized manufacturing alone cannot win a war because it can't be protected. Two, large pre-war stockpiles are not enough to solve the attrition problem. And three, if you're not thinking with low cost in mind when you build stuff and you're designing things for mass manufacturing, you're going to have a problem if war breaks out because you need to be able to build lots of stuff really quickly to be successful. Take, for instance, the Iranian Shaheeds. The United States has bombed, the crap, that's the technical term, out of Iran. And yet almost every single day, they're putting these Shaheeds into the air. So they started with a large pre-war stockpile, but they also have decentralized manufacturing, allowing them to build these systems and continue to get them into the air. What we've seen here is that a large stockpile is not enough because in a war of attrition, having systems that you can build again and again and again and repeat and put into the air is how you're actually going to either defend your country or defeat your enemy. So one of the ways in which they do this, both in Iran and in Ukraine, and I'm sure we'll start to see this in Russia to a larger extent, is by using distributed manufacturing. The Ukrainians have 3D printers across their battlefields. The Iranians have designed a very simple Shahed-style drone where you can kind of stamp the things out. The whole point is you got to do this in multiple places and at times closer to the fight if you want to be successful. To do that, not only need to be able to manufacture the airframes, but you have to be able to source the components that go in. And so what we think here is the companies that are going to be successful moving forward are the ones who have supply chain resiliency. Now, let's move out to a 35,000 foot view here, right? Contested environments, meaning that you don't have control over the air or the sea or the land in order to move supplies around, are now a reality. Look at the Strait of Hormuz is closed, right? And in order to basically fight using distributed manufacturing in a contested environment, which is going to happen in the next couple years, you have to be able to tie into multiple sub-suppliers. One of the ways in which we think that you can do this is you can work with allies to make sure that the components that need to go into whatever unmanned system you're building can be sourced locally or regionally, therefore cutting down the logistical tail on whatever you're building. So let's switch gears here for a second now. Now let's talk about why do we need centralized manufacturing combined with distributed manufacturing. It's our opinion that centralized manufacturing is a way to get very, very high throughput. We believe that, at least at Firestorm, our industrial grade 3D printers also allow for very high throughput because our printers were used en masse during COVID to build millions and millions of pieces of PPE. But if you have a centralized target and you don't have a distributed network, you're leaving yourself up to vulnerability. It could be a cyber attack, a physical attack, but something could go wrong. And what we've seen now, both in the war in Ukraine and in Iran, is that each side that's fighting each other is increasingly going after manufacturing capabilities and critical infrastructure, the things that allow you to sustain a conflict for a long amount of time. So if you have a 500,000 square foot or a 2 million square foot manufacturing site, you are now a target. And if you don't have a way to turn on the manufacturing if that site is blown up or taken offline, then you leave yourself increasingly vulnerable to not being able to sustain combat. Finally, what infrastructure is required to make attritable mass the reality? For us, we think that warfare changes all the time. So you have to be able to have kind of a baseline system that you can build again and again and again, but that can also be modified. That's been one of the main lessons we've learned in Ukraine, is that a lot of the systems the United States sent over there were not able to be easily modified. And so when the Russians jammed those radios, these drones effectively became paperweights because you couldn't get them in the air without them falling down. And there was no way to actually take that radio out and swap a new one in there. So for us, we try and design stuff so that it's truly interoperable, meaning that if you need to put different payloads, radios, sensors on it, because we use additive manufacturing to kind of allow us to modify the airframe, that allows us to basically build something that can continue to iterate as the fight iterates. The other part of the infrastructure we think that's needed, so not just on the product side, like I explained, is actually on the manufacturing side of things. So again, we think redundancy across manufacturing, so doing it in centralized and decentralized manners, as well as software that ties all of these manufacturing sites together and also ties and validates the sub-suppliers that roll up into these manufacturing sites is equally crucial if we're going to be effective to build first tens of thousands, then hundreds of thousands and millions of attritable systems.
Thanks for listening to the Drone Wars podcast. If you liked what you heard today, please subscribe to catch all the latest insights for all things defense and geopolitics.